I was walking to get coffee this morning, and I had this really weird moment of realization.
Oh, yeah. What happened?
Well, nothing happened really. I was just standing at a crosswalk waiting for the light to change, and I looked around, and there's a storm drain right there. The coffee shop is on that specific corner, not the other one across the street. The bus stop is maybe 50 feet down, and it all just feels so organic, like it just sort of sprouted up that way.
Which is actually the illusion of a well-designed city. It feels completely natural, but it's incredibly deliberate.
Right, and that's exactly what hit me. None of this is accidental. Someone, somewhere, made a decision about every single inch of that pavement. But what are those decisions based on? I mean, they aren't just guessing.
Hopefully not. They're basing it on what we call the invisible architecture.
The invisible architecture. I love that phrasing. And that brings us to today's deep dive. For you listening right now, we are digging into a stack of research on the architecture of geographic data and spatial analysis.
Specifically looking at AP Human Geography Topic 1.2, which really breaks down the mechanics of this.
Exactly. It covers a lot of ground, pun fully intended, looking at how we measure and analyze the world. And the mission for this deep dive is pretty simple. We want to figure out how we move from just looking at the world as scenery to actually measuring and understanding it as a system.
It's a massive leap to make. It is literally the difference between seeing a mountain as a pretty backdrop for a photo and understanding that same mountain as a barrier to trade or a source of water runoff or a hazard for a housing development.
So let's strip this down. When the source material talks about geographic data, are we just talking about maps? Because honestly, that's where my brain immediately goes.
Right, a lot of people think that, but maps are really just the end product. They're the visualization. Geographic data itself is the evidence.
Okay.
The definition we're working with here is that this data is the foundational evidence used to understand location, distribution, and characteristics of Earth's features. Think of it as the raw fuel.
So you don't just collect it to draw a picture.
No, not at all. You collect it to reveal spatial patterns.
Patterns that track change over time.
Exactly. Or relationships, like why is the asthma rate higher in this one specific zip code? Or why does traffic gridlock happen at 4 p.m. over here, but 5 p.m. over there? That's not random. It's just data waiting to be read.
Okay, so if we're treating this as an investigation, we need evidence. But the research highlights that not all evidence looks the same. We have this big split between quantitative and qualitative data.
Right.
And I feel like in most fields, people tend to think one is like real science and the other is just sort of fluff.
That is such a common misconception, especially in geography. People think hard numbers, the quantitative stuff, are the only things that matter. But if you rely solely on numbers, you're flying blind.
Let's start with the numbers then. Quantitative data. The source calls this the how many.
Right. This is anything you can count, measure, or put into a spreadsheet. It provides the objective, measurable framework of a place.
Give me a concrete example of this out in the wild.
Well, the census is a big one. This city has exactly 5 million people. That's a hard number. Or elevation, this town is 500 feet above sea level.
Or like the air quality index,
Right.
right? Like particulate matter is at 150 today.
Spot on. Yes.
Okay, so that gives you the dimensions, tells you the box is 10 by 10, but it doesn't really tell you what's inside the box.
Precisely. And numbers can actually be super misleading if that's literally all you have.
Yeah.
If I tell you a neighborhood has high income and low crime based on just quantitative data, you might assume it's a paradise. You might buy a house there.
Right, sounds great on paper.
But the numbers don't tell you that the residents there feel incredibly isolated, or that there's zero sense of community, or that they all hate the constant noise from the highway nearby.
Which perfectly transitions us to qualitative data, the how and why.
Yes. This is descriptive, it's characteristic-based, it captures the subjective experience, the vibe, if you want to call it that.
The vibe of a city, yeah.
It's interviews about neighborhood satisfaction, cultural observations you'd find in travelogues, or media reports on local sentiment. It's the human texture.
I really like the comparison we touched on earlier with the air quality. So quantitative is the index reading 150, that's the
Yeah.
hard science. Qualitative is the interview with the local resident saying, my eyes burn when I walk the dog.
Yes.
Yeah.
And a well-informed geographer or a city planner needs both to understand the full reality. Think about it. If you only have the burning eyes reports, you have a whole lot of complaints but no scientific baseline to actually fix it.
Right, you don't know if it's pollen, smog, or a chemical leak.
Exactly. But if you only have the number 150 cent,
You might not realize how much it's actually affecting people's daily behavior.
Right. Maybe 150 doesn't sound like an emergency on paper, but if it's keeping kids inside during school recess, that's a massive social impact. You have to synthesize the two.
It's interesting because qualitative just sounds softer, but in the source material, it seems just as rigorous if you do it properly.
Yeah.
You have to categorize those interviews, find the themes, code the responses. It's not just chatting with people at a diner.
It's incredibly rigorous. In fact, historically, it was the primary way we understood the world. Before we had satellites and massive census bureaus, we had individuals.
Which brings us to the who of data collection. The research splits this into individuals versus organizations.
Right. It basically divides it by scale and budget.
Let's talk about the individuals first, the explorers and researchers. Because the notes mention Ibn Battuta, and honestly, his stats are like video game level.
They really are. He was a 14th century Muslim scholar. Over the course of about 30 years, he traveled something like 75,000 miles.
And this isn't hopping on a commercial flight. This is walking, riding camels, taking wooden boats.
Exactly. And he wasn't just sightseeing. He was meticulously documenting. His travel narratives, known as the Rila, covered culture, trade, geography, politics. He'd arrive in a city, stay for months, work as a judge, and just write down everything about how the society functioned.
That is pure qualitative data.
It is. And for centuries, that was the map. If you were a merchant in North Africa and wanted to know what Timbuktu was actually like, you didn't look at a satellite feed, you read Battuta. His narratives were so detailed they influenced map-making for generations.
But that's a limitation of the individual, right? One guy can only walk so fast. His data is deep, but it's very localized. It's narrow.
Right. He can tell you everything about the town he's currently in, but he has no idea what's happening 500 miles away. He can't see the spatial pattern of the whole continent.
Whereas the other individual example in our stack, John Snow, feels like he was doing something completely different. He wasn't traveling the world, he was problem solving.
Yeah, Dr. John Snow is basically the godfather of spatial analysis. So we're in London, 1854. There's a massive cholera outbreak in Soho. People are dying within hours of getting sick.
And the prevailing wisdom at the time was the miasma theory, like bad air.
Right. They thought it was just floating around like a fog. But Snow is a skeptic. He thinks it's waterborne. So he starts collecting data on a local scale. But he doesn't just make a list of names of the victims. He acts like a true geographer. He puts them on a map. He marks a black dot for every death at the specific street address.
And this is the real light bulb moment. Because when you just look at a list of names, it's just a tragedy. But when you look at the map,
Bullseye. The deaths were clustered tightly around the Broad Street water pump. But here is the really cool part about spatial analysis. Geographic data isn't just about what is there. It's about what isn't there.
what do you mean?
Snow noticed there were people working right in the middle of this death zone at a local brewery who didn't get sick at all.
Why?
Because they were drinking the beer. They weren't drinking the water from the local pump.
Huh. The one-time drinking on the job literally saves your life.
Yeah. But that's the power of the analysis. The anomaly proved the rule. If it was bad air causing the cholera, the brewery workers should have died too. Because they didn't, it had to be the water. He used spatial data to identify the source and convince the city to take the handle off the pump. He solved a medical mystery using geography.
So that's the power of the individual. But obviously, we can't rely on Jon Snow walking door to door for everything in the modern world. We have to scale up. We move to the organizations, governments, and private businesses.
The big guns. This is where we trade the localized depth of the individual for massive, sweeping scale and huge budgets. The U.S. Census Bureau is the prime government example here.
Collected every 10 years. They try to count literally everyone.
They definitely try. And the stakes for this are incredibly high. This isn't just trivia for a textbook. This data determines representation in Congress. It decides where policy decisions are made and where billions of dollars in federal resources are allocated for schools and infrastructure.
So if the data is off,
It has major real-world consequences. That's why the methodology of the census matters so much. It's quantitative data that dictates political administration.
then you have the private sector.
Yeah.
The business side. The Google example in the notes is fascinating because it totally flips the script on how we think about collecting data.
Completely flips it.
Yeah.
Think about the census. It's active. They send a form to your house. They send people to your door. It costs billions of dollars. Google is passive. They rely on crowdsourced data.
Right, like Google Maps showing real-time traffic patterns.
Exactly. Google doesn't have physical sensors buried in the pavement of every road on the planet. That would be impossible.
No, they just have us.
We are the sensors. If you have Google Maps open and you're stuck on the highway, your smartphone is basically screaming, "I'm not moving," to the server.
And if 1,000 phones scream, I'm not moving at the exact same location?
Google paints the road red on your screen. It is real-time, aggregated quantitative data. We are voluntarily building the map just by driving to work.
It's kind of wild to think about the transition from Ibn Battuta, one guy with a notebook walking across the desert, to billions of us unknowingly building a global traffic map every single morning.
It really is. But that brings us to the how, the toolkit. Because Batuta had a pen and field observations, Snow had a paper map and landscape analysis, we have space robots.
Let's get into that modern shift. Geospatial technology. The source material breaks this down into 3 big buckets: GPS, GIS, and remote sensing,
Let's start with GPS, the Global Positioning System.
which everyone uses every day to navigate or track a package, but I bet very few people actually know how it works. The text specifically mentions a requirement of at least 4 U.S. government satellites. Why 4?
So this comes down to geometry. Your phone is a receiver. It listens for signals from these satellites orbiting the Earth. If it hears from one satellite, it knows you're somewhere on a massive sphere around that satellite. That could be New York, or it could be the middle of the Atlantic Ocean. Not very helpful.
Okay, what about 2 satellites?
2 means you're at the intersection of 2 spheres. Better. It narrows it down to a circle, but that's still a huge area.
3.
3 gets you down to 2 specific points.
Okay.
Usually one is on the surface of the Earth, and one is way out in deep space, so your phone can easily guess which one you are.
Right, I'm not floating in the thermosphere.
Exactly. But to be absolute, to get your exact latitude, longitude, and altitude, you need that 4th satellite to correct for time errors and lock the absolute location down.
So every time I open my map app to find a coffee shop, I'm utilizing a 4-point communication involving government hardware flying at thousands of miles an hour in space.
Yes, it's an absolute miracle of physics that we just casually use to avoid a traffic jam.
Okay, so GPS tells us exactly where we are, but that's just a coordinate, a dot on a screen. That brings us to tool number 2, GIS.
Geographic Information Systems. This is the software. If GPS is the raw data point, GIS is the brain that stores and manipulates it.
The analogy in the notes for this uses the concept of layers.
That is the best way to visualize it. Think of the old, clear transparencies that teachers used to use on overhead projectors. Imagine you have a base map of a city on the bottom transparency. That's layer 1.
Got it.
Layer 2. You drop in a transparency that shows the locations of all the elementary schools. Now you see the city streets and the schools. Layer 3. You drop in a transparency showing all the traffic accidents involving pedestrians in the last 5 years.
And suddenly you see the clusters.
Exactly. You see, oh wow, there are 5 major accidents right in front of this one specific school. You couldn't see that relationship just by looking at a spreadsheet of accident reports or a list of school addresses. You have to stack the different data sets, stack the layers to see the relationships.
So GIS is what lets a city planner decide where to put a new crosswalk, or an investor analyze pollution impacts on an ecosystem.
Or a disaster response team map out flood risks. You layer the elevation data over the housing density data. It allows you to model those complex relationships.
Which leads us to the final piece of the tech toolkit. Remote sensing, gathering data from a distance, the eye in the sky.
Satellites and aircraft. Collecting information about a place without ever physically touching it.
The notes have this incredible example of the Korean peninsula.
It's the classic remote sensing image. If you look at a satellite photo of the Korean peninsula at night, South Korea is blazing with artificial light. It almost looks like an island because of the stark contrast at the border.
And North Korea.
A void. It's almost pitch black except for a tiny pinprick of light at Pyongyang.
And what's really fascinating here is what we are actually doing with that picture. We aren't measuring electricity just for the sake of measuring electricity. We're observing light, but we're inferring economics.
Precisely. That's the key insight with remote sensing. It allows us to infer complex human conditions, wealth, development, isolation, just by observing visible contrast from space. We don't need to send an economist into North Korea to know their infrastructure is struggling. The nighttime lights tell the story.
We also use this heavily for large-scale environmental monitoring, right?
Tracking deforestation in the Amazon is the big one. You can't patrol the entire Amazon basin on foot. It's too big. But a satellite can pass over and spot exactly where the green forest cover is turning into brown dirt.
And for smaller areas, We use aerial photography.
Yeah, aircraft or drones. That's used for high detail checks of smaller areas, like observing rapid urban land use changes in a major city.
So we got the collectors,
Huh?
the individuals and the organizations. We've got the tools, GPS, GIS, remote sensing, and the data types, quantitative and qualitative. But I want to synthesize all this and land the plane on why this matters to you, the person listening right now. Why should anyone care about these layers?
Because you simply can't fix what you can't measure.
Break that down across the applications we've discussed.
We'll look at public health. We talked about John Snow in 1854, but we do the exact same thing today. Preventing disease spread relies on GIS to track where a virus is moving so we know where to send medical supplies.
It's literally life or death.
It is. Then take environmental management. We can't protect ecosystems if we don't know where the pollution is originating. That requires layering soil types, forest cover, and factory data.
And urban planning, which we started with at the very top of the show with the crosswalks.
Why is your commute 40 minutes instead of 20? Because a planner analyzed traffic at intersections to design the roads and stop accidents.
And finally, political administration.
Ensuring fair representation. The census maps dictate your political reality. Geographic data shapes the boundaries of your democracy.
It's so true. We started this by saying the architecture of our world is invisible. But once you understand how geographic data bridges the gap from a 14th century traveler's diary to a satellite orbiting in space, you kind of can't unsee it.
It totally changes your perspective. Geographic data turns just looking at the world into actually understanding the world.
I want to leave you with one final thought on that. We talked about how we've moved from the hero individual geographer, like Ibn Battuta, to this crowdsourced swarm of Google Maps users. If we're all just walking data points now, constantly contributing to these massive maps just by carrying our phones, how does that change the role of the individual geographer?
That is such a good question.
If the map is building itself using our movements, who is actually the explorer? Us. Or the algorithm? Something to chew on the next time you check traffic and see that red line.
Absolutely. It's your data painting that line.
Thanks for taking this deep dive with us today. Keep looking for those invisible layers.
Stay curious.